Great to see you here. My name is Luc de Ceuster, founder of the Ceuster Academy, and in this video I'm going to talk about earned value management, and I'm going to present you some exercise, how to do the calculations, how to find the different parameters. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. First, we have to have a project, and in our project we are in fact completing 20 samples, which are the deliverables, and we want to do that in 10 days. So basically we will be creating 2 samples every day. The estimated cost of one sample is $2,500, and we have arrived at day 6, and the management requests an overview of the project progress using earned value management. We didn't measure anything before, so we're going to look at the situation at day 6, and we will calculate the different earned value management parameters, and we want to see how the project is doing, when do we think the project will end, and what will be the final cost of the project. So let's have an overview here now of the different things. Our team received the following information. We have completed 6 samples on day 6, and the total amount of money spent is $22,000. Now, with this information, we can, in fact, already determine a lot of parameters. And the first thing that we can do here is to create the S-curve and calculate the budget at completion. We want to find the S-curve, also the planned value over the time. And we assume that the samples are produced at the rate of 2 units per day. So we have a total amount of 20 samples in 10 days. Based on the main information, we can determine the budget at completion, which is equal to the total number of samples multiplied with their estimated cost of $2,500, and we find that the budget at completion is equal to $50,000. The next thing to do is to find the relation of the S-curve. And the S-curve is a straight line, and the relation of the planned value and the time is given by PV is equal to 5,000 times T. Why do we have 5,000 here? Well, we have 2 deliverables per day. T is 1 day. So per day we expect to create a value of 5,000. And we can say that the planned value as a function of time is 5,000 times t. We will use that later, and we can draw the S-curve, which we have here. So we start from 0, 0. At the beginning of the project we don't have anything. At the end of each period, and we see at the end of the 10th day we realize the $50,000. And I continue with a straight line because from here on no value is added. Basically, the project is expected to start at day 10, but for construction purposes, I added this line here, which we can use later to do some evaluations. Now, we try to find the planned value at period 6 and the actual cost at period 6. The first thing that we know is that we have the relationship of the planned value as a function of time, and we can calculate the planned value in period 6, which is in this case planned value times t is 5,000 times t. We replace t by 6, and we find that the planned value for period 6 is 5,000 times 6, which is $30,000. The actual cost at period 6, basically the actual cost is reported for every period, and for period or day 6, we know that the actual cost is equal to $22,000. So now we have all the parameters. We have the budget at completion. We have the planned value at period 6. We have the actual cost at period 6. And we still have to calculate the earned value at period 6. The value of the EV is determined based on the number, and I call it N as a function of T, the number of deliverables that have been completed at a certain moment in time. And we can say that the earned value as a function of N is in fact 2,500 times N of T. So N of T means the amount of deliverables that have been completed at that moment. Now the earned value in period 6, in period 6 we know that n of 6 is equal to 6. So we created 6 deliverables, and the earned value at period 6 is 2,500 times 6, which is 15,000. Now we have all the parameters, and we can put all of that in the table here. We have the following information, basic information, that we will need to do the earned value management. We have the budget at completion, 50,000. We have the planned value at 30,000 in period 6 or day 6. That's what we wanted to create. We have the earned value in period 6 is 15,000, and the actual cost in period 6 is 22,000. Now, when you look at these values, we see the actual cost is below the planned value, so we're below the curve, which in the classical approach could lead to euphoria. We are, let's say, spending less money than we basically planned for, and it would create some positive attitude, although we will see in the following parts that it's not really the case. With these values, we can calculate all the calculations, we can calculate all the earned value management parameters, and let's have a look at the graph in which we have the planned value, the earned value, and the actual cost. We have the S-curve, the orange curve, and then we have 3 dots. The orange dot is the planned value in period 6, which is on the graph, and we planned to have a value created of $30,000. The gray is the actual cost, which is 22,000. That's what we actually paid. And the blue dot is the earned value in period 6, which is 15,000. From this situation, we can already see that the earned value is lower than the planned value, smaller than the planned value, so we are behind schedule. The actual cost is higher than the earned value, so it means we are spending more than what we estimated. Parameters that we can use are the schedule and the cost variance. The schedule variance is an indication of the progress of the project, and we can calculate it using the formula. Schedule value in period 6 or day 6 is equal to the difference between the earned value and the planned value on that day. So we find here that the schedule variance on day 6 is 30,000 minus 15,000 is in fact minus 15,000, which is a negative number, which is in fact indication that we are behind schedule. And that's what we've seen in the previous calculations and slides. The cost variance is an indication of how the money to create the deliverable, in our case the samples, is used, and it is calculated with the formula CV is EV minus AC, and we do that again on day 6. So the CV at period 6 is 30,000 minus 22,000 is minus 7,000, so the cost variance at day 6 is minus 7,000, and it is smaller than 0. When we present that on the graph, we see here the graph we've seen before with planned value, actual cost, and earned value. The first thing that we can identify is the schedule variance, which is the difference between PV and EV, and it's a negative, so we are below the planned value, so schedule variance of at period 6 is minus $15,000, and when we look at the cost variance, we see it here on the graph, and this is minus 7,000. Other parameters that we can determine are the SPI, the CPI, and the CSI. The formula of the SPI is given by the SPI, in our case at period 6, day 6, is the earned value at day 6 divided by the planned value of day 6. We go back to the original data and we see that the earned value on day 6 is 15,000, the planned value is 30,000, and we see that the SPI is approximately 0.5. In our case, it's exactly 0.5, but we will have to round some of the data, and when you would do the calculation, when you would have more decimals, the numbers can slightly change. The formula of the CPI is CPI at period 6 is the earned value at day 6 divided by the actual cost on day 6. So we have 15,000 divided by 22,000, which gives us approximately 0.6818. And the final formula, the formula of the CSI, the cost schedule index, is in fact the product of SPI and CPI. So we multiply 0.5 with 0.6818, which is approximately 0.3409. Now what we know with the SPI, the CPI, the CSI is basically that we can determine how the project is evolving. So the SPI is smaller than 1, which is the same as saying that the schedule variance is negative, means that we are in fact only performing at half the speed than we expected in this case. So we are clearly behind schedule. The other formula for the CPI shows us how efficient we are dealing with the money. We're only creating, for every dollar, we're only creating 68 cents of value, which is not really good. And the CSI, it's like a parameter, a combined parameter, and basically we try to have this parameter as close as possible to 1. Once we have the SPI, it is possible to calculate the revised total duration. And the formula is quite simple. So once we know this, we can make an estimate when will the project be completed. Now the formula is simple. We just have to divide the original duration by the SPI. So in our case, the original duration was 10 days. The SPI is 0.5, and we will find that the revised total duration is basically equal to 20 days. Now, it's an easy calculation, but it's not always correct. There are some other parameters I don't want to discuss here, but basically, when we look at the estimation of the duration of the project, it's a better way to look at the Gantt chart and to see what is happening. Now, when we look at this in a graphical way, we can find the, let's say, our estimation, our planned value graph in orange, and we have the gray curve when we say we continue with the project with the same SPI, and we continue until we find the intersection where the earned value is equal to the budget at completion. And that intersection we can find on the x-axis or on the time axis. We can find the time when we achieve this. It is clear earned value is equal to the budget at completion, and this means that the project is completed because all the value has been earned, all the deliverables have been created. Now we can continue here. We can do the same with the actual cost curve. We assume that the rate is the same, so we continue, we extrapolate this curve, and we continue until we reach the end time, in this case 20 days for the project. And when we do the intersection or we do the calculation, we can find here that the estimate at completion in this case will lead to a cost of 73,333 and some decimals dollars for this project. So that's a very interesting way to deal with that. But let's look at the different estimates at completions and the formulas that we can use to calculate it. Now we can calculate the different elements. We can calculate the estimate at completion, the mathematical estimate. And basically, the mathematical estimate considers that the remaining work will be completed as estimated. This basically means that the CPI is equal to 1. So when we are doing a job and we see that the value we earn has the same cost as that value, in that case the CPI is equal to 1. It means that earned value is equal to actual cost. And when we look at this formula, we have to see that first of all we already spent the actual cost. In this case, we already spent 22,000. On the other hand, we also can find out that we finished 6 deliverables and we already earned 15K. Now it means that we still must complete a value of the budget at completion minus the value that we already created. So we wanted to create 20, we already did 6. So we still have to create the remaining amount to value to create is that amount 20 minus 6 is 14. And when we express that in values is the BAC minus the earned value. So when we look at the formula, we have the estimate at completion, the mathematical estimate at completion at period 6 is the actual cost until period 6, plus the remaining value to create, which is the BAC minus the EV, and it gives us 22K for the actual cost. The BAC minus EV is 50K minus 15, which is 35. So the estimate at completion, when we look at the mathematical estimate, we find that this is equal to 22K plus 35K is 57K. Now we can calculate also the other estimates. We have the estimate at completion using the CPI and the estimate at completion using the CSI. The formula for the estimate at completion with the CPI, is basically the same formula that we had for the mathematical estimate, but instead of dividing by 1 the CPI which is equal to 1, we now have a CPI which is different from 1. So we have to divide it with the actual CPI that we calculated before. And what we find here is basically the estimate at completion is here 22K plus the difference, the remaining value to create, which is the 50K minus 15K divided by 0.5. And when we add those values together, we see that the estimate at completion with the CPI is approximately equal to 73.3K. For the CSI, we have basically the same formula, but we replace the CPI by the CSI. And what we find here is that we now divide the remaining work to be completed by 0.349. And we find that the estimate at completion with the CSI is in fact approximately equal to 124.7K. Now we can also apply this using the PERT and the 3-point formulas, and we can also find the 80% value. Like we said, we try to have about 80% certainty or only 20% uncertainty about the estimate, and we can calculate this. Now, when we use the PERT formula, we find the estimate at completion, so we have optimistic plus 4 times probable plus the pessimistic divided by 6, and we find the standard deviation as the pessimistic minus the estimate, optimistic divided by 6, and when we do that, we find the estimate at completion with the PERT formula at 79K approximately. The standard deviation is around 11.3, and we have 80% value, which is 88.658. Now we can do the same thing for the estimate at completion with the 3-point formula. So the formula is a little bit different. We have the optimistic plus the probable plus the pessimistic divided by 3, and we find the standard deviation with the 3-point estimate as the pessimist minus the optimist divided by 5, and we find the following formulas. So the estimate at completion for the 3-point is 85,000. The standard deviation is 13,500 approximately, and the 80% value is around 96,390. Now these are the elements you see. Like always, the PERT, the 3-point estimates are always a little bit higher than the PERT estimate because of the formula, because of the nature of the product of the system. Now when we look at this, we also have to vary something. We still have to evaluate the project manager's estimate. The project manager will give an estimate, and what do you think about the estimate? Let us say that the project manager's estimate at day 6 is that he thinks or she thinks that the project will be finished with a cost less than 87,000. Now, is this a good value? What do you think about that? Well, when we look at the values that we did, we see that this is between the range of the values that is clearly between the optimistic and the pessimistic value. Now, when we look at the estimates at 80%, we see that the estimate at completion for PERT with a probability of 80% is 88.7K. So we're at 87K. So it's very close. When we look at the 3-point, that estimate is 96.5, so it may be a little bit different here. Anyway, we are in the range, and we can always ask for some confirmation depending on the questions that we have. But at first sight, this is an acceptable estimate, and the project manager can use this estimate to continue with the project. So that was it for the calculations related to earned value management. Earned value management is not so easy. I try to give it or explain it with some simple examples. Basically, it's very important to understand where your project is going and to share with the stakeholders what is happening with the project. And you have to give a realistic approach evaluation, and it will give you the possibility to take the necessary actions. It will help you with unfounded optimism and also with unfounded pessimism. When we look at the estimate, when we have an estimation of the project manager made an estimation how much the project he or she thinks it will cost at completion, we can calculate what we call the to-complete performance index, or the TCPI. Now, the TCPI is a very important parameter because from the moment that we have a new estimate, a new goal to finish the project, we can estimate how realistic is this. If the TCPI is larger than 1, it means that we have to have a very good performance, and we have to see that the work is done at a lower cost than estimated. On the other hand, when the TCPI is smaller than 1, then it's easier to reach the goal. Now, the formula is in fact quite simple. So we want to understand how we get there. We can find the formula based on the original estimates when we have the estimates at completion with some mathematical manipulations. We find that the TCPI, let's say in period 6, in day 6 here, we have the budget at completion minus the earned value at day 6 divided by the estimate at completion, the value that we selected, minus the actual cost at the period we are evaluating. In our case, the project manager estimated that the project would cost at completion 87K. And when we put the numbers in there, we find in the numerator 50K minus 15, which is 35K. In the denominator, we have 87K minus 22K, which is equal to 65K. And we find the TCPI, which is equal to 0.5385. In this case, it's a quite comfortable situation for the project manager, but I assure you, it's not always the case like this. That was it for this video. Thank you very much. And before you leave, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you, and bye-bye.